Hello everyone. Today I am going to discuss the fifth problem of AtCoder beginner contest 360, which is random swap of balls. So we are given n minus 1 white balls and 1 black ball. These are in balls arranged in a row with the first ball being the black ball. Okay, or the leftmost ball being the black ball. Okay, so Takashi will perform the following operation k times. Choose an integer uniformly at random between 1 and n, inclusively twice. So you will choose two integers a and b, and these two operations are independent. Okay, swap the eighth ball and bth ball from the left. After k operations, let the black ball be at the x position. Find the expected value of x modulo this thing. Okay, so what is the problem? Let's take the first example only. There are two balls and k being 1. Okay, 2 1. That means the first ball being the black ball and the second ball being the white ball. Now we have to choose two indexes I and j, or a and b you can say, separately, independently. So the total possibilities are 4. So it could be either 1 1, it could be 1 comma 2, it could be 2 comma 1, it could be 2 comma 2. In both the cases, in all the cases, what is the configuration after doing this operation? So we are changing the first ball, swapping first ball with first ball, so it is not making any difference. Now in the second case, we are changing the first ball, swapping the first ball and the second ball, so it will be WB. 2 1 is similar. Okay, so 1 2 and 2 1, I comma j and j comma I are doing nothing different, so will also be w comma b, and here we are changing the white ball to white ball. This will be bu w. So in these two cases, the ball is at uh, uh, the first position. So we can say that the probability is 2 into 2 by 4. The probability is 2 by 4 into 1, and 2 by 4 into 2, 2 by 4 into 1, and 2 by 4 into 2. So it is nothing but this will be half, and this will be our 1. So answer will be 3 by 2. I hope you get it. Here you can check, the answer is 3 by 2. Okay, the expected value is 3 by 2. Now here, after seeing this example, you might think that after doing one operation, that the probability of the ball being at any index is same, half. I also thought that after seeing this example, and I thought that the problem is quite straightforward. But no, if we change the number of ball from 2 to 3, the answer will differ by a lot. Okay, so 3, let's say 3 1, then we have BWW, uh, and we have 9 possibilities, right? So the possibilities, let me write: 1 1 1 2, 1 3 2 1 2 2 2 3, and similarly 3 1 3 2 and 3 3. So let's write all the configurations after swapping these balls. Okay, so the first case, it will be BWW. After the second case, it will be our WBW, and after the third case, it will be I think WWB, yeah, WWB. 2 1 will be nothing but 1 comma 2, so it will be WBW. 2 2 will not be changing the initial configuration, BWW. 2 3 will also be not be changing the configuration, so BWW. 3 1 means 3 1 means 1 3, so we can say WWB. And 3 2 means this will not also change, so it will be BWW. And 3 3 will also not change the initial configuration. So here you can see that how many cases the ball is at the first position: 1 2 3 4 and 5. So among the probability of the ball being first position is 5 by 9, so 5 by 9 into 1. And among the others, there are two possibilities where the ball is at the second position, so 2 by 9 into 2, 2 by 9 into 2, and uh, among the other positions, sorry, third position, the ball can be at 2 by 9, so 2 by 9 into 3. So the total expected value is nothing but like this: 5 by 9 into 1, 2 by 9 into 2, into 2 by 9 into 3. So what is the observation? The first observation we can make from here. The first observation I have made is that the probability of the ball being at the first position is something. Okay, and the probability, this is something, let's say P1, and the probability of 2, the ball being at 2, the ball being at 3, and the ball being at anything other than 1, okay, is something, is same. P2 equals to P3 equals to N equals to everything. Okay, this is something, let's say P, and let's say this is Q. Okay, so that is the first observation, that the ball being any index other than n, the probability other than 1, the probability is same. Okay, now how we can calculate this P1 and the others? Okay, now let's say, let me write it here. Okay, now let's say the ball is at first position. Okay, let's say we are doing some recursion. Okay, recursion, and the state is, let's say, is our ball is at the first position, and the number of operations we have done is 0. This is the initial state. Okay, from initial state at 1 comma 0, we can move to what? We can move to 1 comma 1. And what is the probability of moving from 1 comma 0 to 1 comma 1? Okay, so we can take any ball other than 1 at one index, and we can take any ball other than 1 at the other index. So it will be n minus 1 by n into n minus 1 by n. Okay, n minus 1 by n into n minus 1 by n. This is plus we are choosing I comma j as 1 comma 1. So that is nothing but 1 by n into 1 by n. Okay, 1 by n into 1 by n. So this is the probability. This is the probability that the ball being from 1 comma 0, we are moving to 1 comma 1. Now what is the probability that we are moving from 1 comma 0 to anything else? Okay, anything else I comma 1. Okay, anything else I comma 1, from 1 comma 0 to anything else I comma 1, what is the probability? So we can the first ball or the second ball could be the first ball. So it is 2 into 1 by n into 1 by n. Why it is like that? Why it is like that? Because we can take the let's say we can take 1 comma I and I comma 1. These are the two cases when the ball is moving from 1 to I. Okay, so the probability is 2 into 1 by n to 1 by n. Now this is the first step. Now after, so from I we are transitioning from I comma 1 comma 0 to 1 comma 1 and I comma 1. Now this is the first step. Now we have to think about the common step. Okay, how we can move from a step I comma k to j comma k plus 1. Okay, that is the step we have to think. So we have to think. Okay, let me take one moment. So I'm back now. From I comma k, so we are at some state, let's say j comma k. Now from where we can arrive to this state? We can arrive from one state, let's say 1 comma k minus 1, and we can arrive from anything, let's say j comma k minus 1, and we can arrive from anything which is other than 1 and j, I comma k minus 1. So what is the probability from 1 comma k minus 1 to j comma k? The probability is nothing but 2 into 1 by n into 1 by n. Okay, I have told you, na, this is this possibility is when 1 comma j and j comma I, and the probability for this is probability of this is nothing but j comma j. So this is 1 by n into 1 by n. This will only happen when we get something like j comma j, and this could be anything other than this. Okay, this could be anything other than these three configurations. No, not really. The one value could be one value is j, one value is j, and the other value is I and I comma j, and the I values could be anything from n minus 2. So this is nothing but n minus 2 by n into 1 by n and into 2. Okay, this is the transition state from anything from jk. Okay, so let's jump into the code, you will understand better. So we are computing dpi0. dpi0 means that what is the probability that we are at after the I steps, we are at first index. We are at the first index. The black ball is the first is at the first index. What is the probability? That will define as dpi0, and dpi1 means that the ball is at after I operations, the ball is at some different index than 1, because we already defined that probability of 2 is same as probability of 3 and same as probability of n. Okay, so how we are transitioning from dpi minus 1 dpi0 from dpi minus 1 0 and dpi minus 1 1. Okay, so we have to clear something. Yeah, no, we have space left. So we are I comma 0. That means that we are at the first index. Okay, the black ball is the at the first index. So that that could happen if the if at the I minus 1 step we are at the first index I minus 1 into 0, and we have chosen uh, anything, let's say I comma j, which is where I comma j is not 1. I comma j is not 1, so it will be n minus 1 by n into n minus 1 by n. Now other possibility is that we have chosen 1 1. Okay, we have chosen 1 1, then it is plus 1 by n square. Okay, so this is I minus 1 0 plus 1 by n square, and the other probability is that we have chosen anything else and anything else and 1. So let's say 1 comma 1 comma j, we have chosen in 1 comma j. So the probability is I minus 1 comma 1, the probability I minus 1 comma 1, and we have chosen 1 by n and n minus 1 by n, and so 1 comma j or j comma 1, so we have to multiply it by 2. Okay, we have to multiply it by 2. So let's jump here. So we are taking 2, we are taking 1 by n square as common, so dv is nothing but 1 by n square. So it is n minus 1 square plus 1 into dp I minus 1 0 plus 2 into n minus 1 into dp I minus 1 1. Okay, so we have made the transition for 1, the ball is at ball being at 1. Now let's figure out if the ball being at anything other than 1. Okay, I1. Okay, what is the probability of I1? So I1 means that the ball is coming from 1. This is one probability, the ball is coming from 1. So that probability is nothing but we can choose 1 comma I and I comma 1, 1 comma I or I comma 1. So it is nothing but 2 into I minus 1 comma 0. That is one probability. And the second case is that ball being at this current index, the ball is being at the current index, so we can choose anything other than this. Okay, so that means the same as this, n minus 1 by n, n minus 1 by n into n minus 1 by n, and plus 1 by n into 1 by n into I minus 1 1. Okay, this is that the ball is at our current index j. And another case is the ball is other than 1 and j, that is this is all in some other index. In that case the probability is we can choose one j and another one as k, any other ball. Okay, the probability is nothing but n minus 2 by n into 1 by n into 2 into dp I minus 1 and 1. Okay, that is the step. So the first step is that the ball being at the current index. The second step is being that the ball was at the first index and moving to the current index. That's why we are multiplying it by dpi minus 1 0. And the third step is that the ball was not at the current index, but the ball was not at the first index also. So it is coming from any other n minus 2 indexes. Okay, so we got it. After that, after we find this, the probability will be dpk0. The ball is being at the current index, the we have to multiply it by 1, and otherwise our current sum is 1 plus 2 plus 3 plus 4, which is n into n plus 1 by 2. So s minus 1, and we are multiplying it with dpk1, because dpk1 means that for anything from 2 to n minus 2 to n, the probability value will be same, so we are multiplying it by s minus 1. Okay, and at the end we are printing the answer. This is a good question. I think it will clear doubts about expected value, and I hope you got the explanation. If you have any doubt in any part of the explanation or code, you can always ask in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video and subscribe to my channel. Thank you.